Welcome to the 15th lecture of this course. This also makes the 5th lecture of third week. So, friends, in our last lecture number 14, we in detail discussed about the greenhouse. First of all, we talked about the positioning of Earth in galaxy and universe. So, it has given us an advantage to have to maintain a temperature what we are having. And then we also have greenhouse gases in the atmosphere that has given a kind of relatively higher temperature or higher effective average temperature, you say, to the tune of 33 degree centigrade. So, that keeps our average temperature about 15 degree plus. And then we went on to understand and discuss about the pattern in terms of last 500 million years. So, we found that 4 times it has altered between ice house and hot houses. And then we are currently somewhere at a little warm phase of the last ice house, right. And then we try to understand this with respect to the pre-industrial era. As far as the data analysis is concerned, we are taking it 1850 to 1900 average as far as the IPCC report is concerned, but you will find here and there some other comparison, but it refers to the pre-industrial era for comparison. And then when we compared, we found that the average temperature has already risen by 1.1 degree, and that also is there is also a disparity. Over the land it is 1.59. Over the ocean it is 0.88. So, with this we came to an understanding that yes, Earth average surface temperature has fluctuated 4 times between 10 degree to 30 degree centigrade in past half billion years. Our Earth is close to 4.54 billion years old. So, evidently when we have analyzed the data of past 500 million years, we found that the average temperature have been settled between 10 degree to 30 degree centigrade. And now in today's class, today's lecture, we will try to understand what are the various projection. We in our earlier classes like class number 11, 12 and 13. We discussed about the projection scenarios. We discussed about IS-92. We discussed on a SRES scenario, then we moved on to understand the RCP representative concentration pathways, and we also in the third one, that is the 13th lecture, we understood about the SSP scenarios, shared socioeconomic pathways, right. And with that understanding, scenario understanding, and with the understanding of Earth's average temperature, let us discuss about the projections, the future projection with respect to 2050, 2070, 2080 to 100, that means end of this century, using some of those scenarios. So, let us see what are the projection scenarios, and to do that we are going to cover these 6 concepts. So, first is the climate is warming. First thing we will discuss is that climate is warming, and it is more so because of our activities, or we say anthropogenic activities. Because in our last class, the 14th class, we discussed about the greenhouse gases, and the warming or the warming in terms of greenhouse gases is more so in current era, in the industrial era, which we attribute to human activities. The second, we will talk about the scenarios which are linked to various global warming levels. So, the scenarios as I just mentioned, we will see the latest few in terms of RCPs and SSP scenarios. And then we will move on to understand the observed extremes and the human contribution. We will see that across the world, and we will try to understand the extremes in temperature. Friends, we all know that the impact of climate change the impact of climate change has been realized by the humanity in terms of extreme weather events. So, one of them is the extreme temperature. We receive several hot days these days in terms of over an year, we receive several hot days. And we will also try to understand what are the observed trend, and if there are some bias, what kind of bias they are, that also needs to be understood. So, that we will see how confident we are in terms of this kind of indication or the result what is being shown. Then we will also see in terms of the land area, we have land and oceanic distribution over the earth surface. So, how much percentage of land area, because we live on land. So, the human being live on land. So, how much a percentage of area of the land is affected by extreme temperature? We need to be worried for that, and we need to do something. So, for that, so we need to understand how much percentage by if the temperature goes rises by 2 degree centigrade in comparison to our pre-industrial phase, or if it is by 3 degree in comparison to our pre-industrial stage or phase. Okay. Then towards end we will discuss about the temperature projections of India and the heat waves. So, as far as the Indian subcontinent is concerned, our own country is concerned, we will try to understand how is the projection pattern across different regions, different states, and at different or a kind of monthly or seasonal, and then we will try to see the heat wave pattern, because heat wave is one of the extreme realization of the temperature, and it has been taking a toll. It has been taking a toll. So, in past 2 decades the death has gone to more than 30,000 according to the reported cases. So, it may fluctuate based on different reportings, but what I wanted to tell you or inform you that yes, heat wave has started taking a toll in terms of human lives, and in addition it is beyond our scope in this lecture to discuss about how much other biota has been affected because of the heat waves or the extreme temperatures. So, let us move on. In terms of the contribution, look at the curve very carefully. On the y axis, it is always the change in the global surface temperature, that is the annual average, that has been shown from 0 to 2 degrees centigrade, and on the x axis the period between 1850 to 2020, and the observed pattern, the upper one, the observed pattern shows in terms of a black curve that till 2019, okay, the pattern of temperature rise in comparison to 1850 is this. Now, look at the other two curves. One is the middle one, the middle curve is the simulated, that is using different models. Okay. It talks about the contribution or the drivers in terms of the contribution by both the human or anthropogenic forces and the natural causes. Friends, in our first and second week, we have already discussed about the drivers or the mechanism of climate change. There we have discussed the natural causes very elaborately, and we also have discussed the causes of human or anthropogenic in terms of greenhouse gases emission or other alterations. So, when we simulated the human and natural impact, it is almost matching to that of what is being observed. But then when we remove the impact of anthropogenic, that means human influence, then you see the curve that is coming down below in terms of a sand kind of curve is showing a almost it is almost the same. It is almost the same or very minimal increase. So, the pattern is it is almost comparable with respect to 1850 to 2020. So, it is very clearly evident that the current warming of 1.0 degree centigrade plus is mostly because of the or due to the human or anthropogenic factors, not because of the natural forces or the natural factors. Now, in this slide, let us also talk about the annual mean temperature change, and then you can see this global figure here, and somewhere down towards this the southern hemisphere you can see the missing data where is no calculation, so nothing to worry, and the scale is between minus 2.4 to plus 2.4 in terms of annual mean temperature change. So, it is, please remember, this is a annual mean, and on this side you are seeing in terms of the latitude bands from southern to northern, and the mean as far as the zonal mean is concerned, you can see lot of in terms of the four curves. The red one is observation by Berkeley Earth, the other observation data sets thin red color, then this is a model simulation of CMIP 6 of 45 and 5 to 95% in terms of the model range have been considered. So, here if you see on the northern hemisphere towards the polar region, or we say it high latitude. So, towards higher latitude the increase of mean annual temperature is very, very high, and there is also some increase in terms of the high latitude on the southern hemisphere. So, friends, what is the understanding or the realization from here is that yes, at both the higher latitudes the annual mean temperature have increased in comparison to the annual mean temperature have increased, and then here you can see it is more or higher in terms of the northern hemisphere. So, change in temperature at a global warming level of 1 degree centigrade. So, you see since pre-industrial times human activities have caused approximately 1.1 degree centigrade of global warming. At current rate the world would reach 1.5 degree centigrade somewhere between 2030 to 2052. So, the rate, or you say the BAU scenario, business as usual scenario, if we go, then perhaps by 2050 or mid of the century approximately the world would reach or receive an annual an average surface temperature of about 1.5 degree centigrade rise than in comparison to the pre-industrial era. And let us move on to the scenarios in terms of global warming levels and the patterns of change. Here again on the left hand side you can see with respect to the SSP 3, shared socioeconomic pathway 3 and SSP 1. So, you can see the corresponding in terms of the global warming. So, 20 years in terms of GSAT means have been taken here and have been plotted. So, all these SSP 1 curves which have been shown by different model runs have been shown here, and all are below 3 degree centigrade. They are predicting temperature rise below 3 degree centigrade by end of you can see 2070 or this is something about 2090 here. And then rest, or if you follow SSP 3 scenario, all of them are projecting temperature rise beyond 4 degree or up to 5 degree also. So, this the take home message is, when we use this kind of scenario based predictive analysis, it gives us at what rate we are going, what kind of policy mitigation, what kind of scenario we are following. So, based on that, if we follow that, we will end up with this kind of temperature or global mean temperature. So, this spatial distribution as far as the globe is concerned, in a scenario of average of you can say 1.5 degree centigrade, and this is 2 degree centigrade and this is 4 degree centigrade. You can see this is really you can be afraid of. So, we do not need to be there with 4 degree plus in terms of the temperature rise by end of this century. So, scenarios are linked to global warming levels. Not all simulations reach all levels of warming. As you can see here, the SSP 1 parallels with 2.6 watts per meter square as far as the warming potential is concerned. They are all below 3 degree, and all in contrast all with respect to SSP3 having close to around 7 in terms of global warming parts per meter square are going up to are going between 3 to 5 degrees centigrade. So, this is what is we need to understand what rate if we follow certain rate where we will be or where we will lead to in terms of the global warming or global mean temperature. Same also we can try to depict, we can try to dissect based on the what you say days or months. So, you say yes, I will get means by end of this I will have 1.5 degree in terms of temperature rise. Now, we have already received somewhere more than 1.1 in comparison to pre-industrial. So, by end of mid century 2050 we will have somewhere 1.5. So, another about 0.4 degree temperature rise. So, if that is look at this one, then this part of the Amazon, okay, Amazon basin or the Brazil, here in this part we will have a kind of how much of days per year we will have a kind of warming or heat warming index is shown here. If you see here somewhere maybe 3 months per year we will experience in terms of heat. Okay. Over India and particularly this one, because this is the size of the grid, a very large size. So, here you can see the southern part will receive somewhere between 1 to 3 months per year in terms of the heat warming index, and you can similarly see the global warming levels in terms of different places across the world with respect to 4 degree or predicted 4 degree or projected 4 degree temperature rise. So, how many days or how many months per year we will experience the heat warming in terms of the heat warming effect. So, what we observe from here, the tropics, you can see the both sides of the equators are going to be warmer at a much faster rate than that of the higher altitudes, higher latitudes, I am sorry, in either of the hemispheres. So, you can understand and interpret in that way. Now, with respect to the surface air temperature rate anomaly relative to again 1850 and 1900 average. Now, here if you see in terms of the surface air temperature rate anomaly, this is deviation from the mean. So, which is shown between minus 10 to 10 degrees centigrade with respect to this, and you can see various places have various rate of increase. You can see on the on both side of the higher latitudes in either side of the pole, it is a very high rise in terms of temperature that is shown the rate of change, or you can see it in terms of the rate anomaly in comparison to the pre-industrial time period. Now, when we analyze this or try to understand this in terms of extremes, we come out with cold, hot, wet and this kind of situation, and as far as the human contribution is concerned. So, heat extremes are well attributed, rainfall attributions are more uncertain. We will cover it in terms of the rainfall in our future classes, and the regional attribution varies. Something will happen to this region which is because of that local or regional factor. Let us say we have a monsoon pattern in the South Asia. So, it will have a different set of conditions as far as the temperature, the rainfall, heat extremes, everything is concerned. So, the regional confidence varies. Natural forcing alone is insufficient to what you say to take us to that kind of situation. So, anthropogenic forcing increases the livelihood of extreme events. So, anthropogenic starts with us. So, human induced factors are actually becoming important or causing the faster rise in temperature. So, projected changes in the frequency of extreme temperature. Now, look at the way this temperature extremes or temperature rise are being analyzed. So, the changes here in terms of the frequency of the temperature, if you see, the gray one talks about the 10-year event, and the magenta one or the orange color one talks about the 50-year level and number of times in the when the y axis it is shown as the number of times as the frequency, and in the x axis it shows the temperature change. So, this kind of regional analysis is extremely important. There we see the rare events, that means 1 in 50 years increase non-linearly, you can see here, and the dotted lines particular no change as far as the CMIF 6 coupled model intercomparison phase 6, and SSP stands for your shared socioeconomic pathways ensembling, and then the frequency changes exceed intensity, the intensity changes. Now, having understood this, so we interpreted this in various ways in terms of knowing the cold, hot and areas and the extreme event variations. Now, let us understand the observed trends and what are the bias within this. Friends, in terms of the upper two, the left side, you can see the annual hottest temperature in terms of the widespread positive trends, intensification of hottest days, and then the annual coldest temperature, that means strong warming especially at high latitudes, fewer cold extremes, and you can see that the annual hottest temperature and annual coldest temperature, they are very well emerging, and the bar is between -1 to +1, whereas down below when we take the this is the observed, means some 1960 to 2018. Now let us see the simulated one in terms of the multi-model mean bias in temperature extremes. Here you see the extreme lower left, the bias in annual hottest temperature, and the lower middle or lower right you can see bias in the annual coldest temperature. So, we interpret our observed trend in terms of what kind of bias can be there. So, that gives us what you say idea about how many hot days increase globally. So, the trend pattern what you are seeing here, you can notice that globally it is consistent, though there could be gap in the data. The data gap always exists, but trends are so robust where data are available. So, that means wherever data is there, the trend is very robust and prominent. So, CMIF 6 extremes are well reproduced. There are large biases, particularly in data sparse region and the complex terrain or the mountain kind of regions, and confidence level, as far as the confidence level goes, the simulated extremes are very reliable. And with this, let us go on in terms of some examples across the world, various regions. So, as far as the case studies and published material is concerned, the lower left you can see the concurrent climate events, and it shows the extreme events because particularly one event between 2015 to 2016 where the extreme El Nino kind of condition was there. So, because of this extreme El Nino between 2015 to 2016, you can see as far as India is concerned, in May 2016 very high temperature was observed. In December 2015 extreme rainfall was received. So, these are the extreme impact of extreme El Nino events during 2015 to 2016. Now, look at the upper right hand side of depiction as far as the percentage of land area affected by temperature extremes. So, friends, if you see here on the y axis we have put the land area in terms of percentage, and on the y prime axis it is taken the JJA, that is the June, July and August month between 30 degree north latitude to 80 degree north latitude. So, you can see a little of the middle to high latitude have been taken. And then more importantly, if you see if you try to follow the blue curve which indicates the temperature is greater than plus or minus 2 sigma. So, there you see the extreme temperature will include up to 15% of the land area, whereas if it is 3 plus sigma, then it could include up to this much what is shown, little lesser land area what is shown as using the magenta magenta curve. So, accordingly you can read and try to understand the regional what you say the how different regions have been affected as far as the left side extreme event in terms of 2015-16 El Nino is concerned, and a kind of how much percentage of land area could be affected because of the temperature rise with respect to plus 2 or 3 sigma between certain between the mid to high latitudes of the northern hemisphere. Now, friends, let us take some examples as far as our own country is concerned, the Indian scenario. Friends, if you see this particular state-wise heat wave days trend, which is plotted between 1970 to 2021 in India. So, what happens over the plain land? If the extreme temperature or the maximum temperature is going beyond 40 degree centigrade, then we say that yes, it's for plain area it is maximum is reaching up to 40, and then beyond that whatever, let us say up to 4 to 5 degree centigrade rise in terms of the higher temperature is concerned, we put it under heat wave demarcation. If it is more than 7 degree, we put it under severe heat wave demarcation. And in contrast to the mainland, in the mountain areas, when we go for the mountain areas, there the maximum temperature is relatively lower than what we receive over the plain land. So, in the mountain regions, the higher temperature, okay, if it's going up to 30 degree in an average, we consider it. So, beyond 30, if it is going up to another 4 to 5 degree centigrade, then we put this that it is a heat wave kind of condition over mountain terrains, and similarly more than that we put as a severe heat wave condition. So, what you need to remember is the 10 degree difference between the plain and mountain. So, now look at all the 12 seasonal defection, and using the very extreme left hand side where the number of heat wave days have been put there. So, in terms of the number of heat wave days, it has been taken per year from 0 to 35 days. So, 35 days is approximately 10% or 9.5% days of the year are going under heat wave condition. Look at the what you say 2010. I would say in this the second left the second row and the extreme left, you can see there it has gone up to 15 to 35 degree 15 to 35 days of heat waves per year in 2010. Even you also go to 2012, in these areas it has gone in 2010 and then 2012. And similarly, you can see the extreme upper left is 1970 to 79, then the second upper left is second upper row is between 1980 to 89, and then 1990 to 99, and 2000 to 2009. This is between a range, but then when it has gone from, it has been shown between 2010 to 2021, you can see the annual pattern as far as the number of heat days our country have experienced between 2010 to 2021. Now, friends, as far as our country is concerned, India is concerned, what is the temperature projection that has been picked from different literature based survey published in this paper by Ravindra et al. In 2014, just last year. You can see the ninth one, which is saying the regional climate model, global climate model, and 6 models used, A1B scenario as far as SRES, and projection with respect to baseline 1975 to 2005. So, with respect to that, they have found that 0.9 degree centigrade by 2020, which is already gone and looks like it has happened. 2.1 for 2050 in futuristic and 3.4 by or for 2080. So, similarly, you can see this kind of average mean maximum temperature projection have been given by different studies for India. And the heat wave, come to the fourth column as far as the heat wave condition is concerned. So, projected to increase by 40 times by 2100, by 4-fold by 2100, hottest summer rise more than 7 to 20-fold as compared to present climate. So, various kind of projections are coming as far as the heat waves or the extreme temperature or the temperature extremes are concerned. Now, the global pattern also on the very left hand side you can see the world temperature record between 2014, it is a record, it is the observational record between 2014 to 21, and you see from 2014 to 21. So, here is if you focus there, in the year 2016 the hottest year as we have seen in case of our El Nino kind of situation, 1.23 hottest year on record, and 2020 we got another 1.23 in terms of the hottest year. So, in last decade we have already received 2 hottest years. So, that is another way of interpreting how many hottest years or how many extreme years in terms of temperature, extreme temperature years we have receiving recently or means very recently. So, now the second part of this slide goes to what are the reasons as far as the heat waves in India is concerned. I have noted it, though this is little beyond the scope of this particular class, but I thought to put it here in terms of 6 points. One is, I will read it out, anticyclones in western India. So, rapid intensification of the subtropical anticyclone in the Arabian Sea repels monsoon flow, slows the monsoon's advance, thereby significantly impacting India's heat waves. Number 2 point is the rising temperature in the Indian Ocean. The warming of Indian Ocean has been substantial since the turn of the millennium. Third point is absence of periodic rainfall. Since 1970, several regions of India has seen a significant decrease in precipitation, which is leading to the heat wave conditions in India. The fourth point is soil moisture deficit. The areas of southwestern India experienced a substantially significant monsoon rainfall deficit and water storage losses in 2016, which were hit hard by the severe summer. Coming to fifth one, influence of absorbing aerosols on heat waves. Anthropogenic aerosols, primarily composed of radiation scattering sulfate, cause an overall cooling, while greenhouse gas induced warming exacerbates high temperature extremes. And the last one, the sixth one is heat wave associated mortality. Heat wave pose a substantial risk. There could be cramps, dehydration, fatigue, heat stroke also. So, it is associated with mortality. So, let us understand that this has already started happening and we have already received lot of mortality over past few decades. And I followed these two literatures, IPCC and the published literature by Ravindra et al. Appeared in Helion very recently. And I will repeat what we have discussed. We have discussed these 5 points and try to understand the different projection scenarios, and as far as India is concerned, how the extreme temperature and particularly the heat wave patterns, and we also try to attribute it in terms of an example as far as the extreme weather events is concerned. So, El Nino also we have taken as an example that happened in 2015-16, and with respect to that there have been in terms of annual mean temperature rise of 1.23 degrees centigrade itself in that year. So, this is what we try to understood in this week number 3. I will repeat, week 3 we talked about all those scenarios, the SI 92, the SRES, the RCP, the extended projection scenario, the SSP scenarios. Then we talked in detail the the temperature, the average temperature, the absolute temperature, the year in terms of the pre-industrial phase as the comparison, as the base year for comparison, and then different projections including the heat waves and extreme heat wave kind of conditions what we have started experiencing, and some projections across the different regions of the world and particularly over our own subcontinent and our own country, that is India. Thank you very much.